Okay, so let's do an example of marginal productivity of labor. So I'm just going to divide this into columns, right? Let's do an example. So let's say we have some number of workers, 0, 1, 2, 3, and 4, and some, output. This is total output. And we could say, marginal productivity of labor. Okay, and let's say that we have, if you have no workers, your total output is going to be 0. You can't do anything without workers, right? If you add with 1 worker, you can make 10. With 2 workers, you can make 21. Let's do 26 and 29. Okay, and we're going to assume that every single worker is equally productive. Okay, so no worker is better than the others, right? They're all exactly the same in every single way. There's no difference whatsoever. Okay, a bit unrealistic of an assumption, but we're going to make it for now. Okay, so what is the marginal productivity of labor for the 0th? Well, that doesn't exist, right? Can't have -1 workers. That'd be, if you could find a way to have -1 workers, that would be pretty wild. Okay, so the first worker, by showing up, adds 10. Okay, and we can show that using this equation, right? The change in quantity is equal to 10, and the change in labor is equal to 1. Leading scholars contend that 10 divided by 1 is in fact 10. Okay, let's do the next one. So once again, the change in quantity is equal to 21 minus 10, and the change in labor is equal to 2 minus 1, so that equals 11. Okay, and we can keep going with similar analysis. We'll see that this is 5, right? And this one is 3. Okay, now you can do this, in a much simpler way since we're doing it by 1 every time, since we're always going to be dividing by 1. You can see it as the change in output. Okay, but if you don't have data, so let's say you didn't have data for the second one here, right? How could you figure out the marginal productivity of labor of the third one? Well, what you would do, right, is you'd go from 10 to 26, right? So that's 13 up here. Let me get a second pen. I can actually do this. All right, so second pen, we'll do it in red. All right, so 20, so change in, oh, this is too small. Get a bigger pen for you. There we go. So change in quantity is equal to 26 minus 10. Change in labor is equal to 3 minus 1. So that is 16 divided by 2, which equals 8, right? Which is a good enough or close enough approximation for what you'd be working on, which actually, lo and behold, is also the average of these two things, right? So it's a good average estimate, right? Each one of the second and third increase or marginal workers is adding on average 8, right? So it's close enough, not perfect. Obviously, the more data you can get, the sharper your analysis can be, but you can do it with anything, right? You can get the average across them, no problem. Okay, so this is how we would calculate the marginal productivity of labor.